Hi students, welcome to Civilianz class. My name is Gokul and I will be the one who is handling environmental engineering for GATE. So let's begin with the subject. Environmental engineering has on an average it has about 12 mark weightage. It has about 12 marks weightage for GATE exam. So you have to know it is one of the most important subject that you should study. Okay, now let's begin. There are mainly four units in environmental engineering, which are water treatment, next waste water wastewater treatment, then solid waste management, and air pollution and control. So these are the four units which comes under environmental engineering, and I must say that it is one of the biggest subjects you are going to study. So there is a trick for studying this subject, environmental engineering. Just remember it like a story. Okay, we will get there eventually. Okay, no need to worry about that. Let's begin with the first chapter, that is water treatment. Water treatment. The story goes like this. You are going to build a water treatment plant in your locality. So what will you guys do for that? Every civil engineering structure needs some design and all, right? So for building a water treatment plant, most importantly, there are three parameters that you should consider. Those are, sorry, I must say the chapter name first. So first chapter is population. First chapter is population forecasting and water demand. Population forecasting and water demand. This is the first chapter. So in this chapter, we are doing all kinds of design related to this water treatment. So the story goes like this again. There are mostly three important parameters we should consider while designing a water treatment plant. They are rate of demand, next design period, and population. We have to study in detail about these three parameters, namely rate of demand, design period and population. What is rate of demand? First we have to study about rate of demand. What is rate of demand? It is the average amount of water. Required by an individual to fulfill all his daily needs within a day. It is the average amount of water required by an individual to fulfill all his daily needs within just 24 hours. It includes its bathing needs, his cooking needs, its cleaning needs, its toilet use. Everything comes under this rate of demand. And what is its unit? It has been asked many times in various exams, competitive exams, including GATE. What is the unit of rate of demand? Its unit is LPCD, liters per capita per day. Not only that, liters per head per day, liters per person per day, liters per capita per day, liters per person per day, liters per head per day. All are the units of rate of demand. And how is rate of demand calculated? Rate of demand is calculated by rate of demand. First we calculate yearly demand. Then we have to divide it by 365. We are calculating rate of demand like this due to the seasonal variations can happen, right? For example, in rainy season, we consume comparatively less water when compared to hot summer season, right? So, due to that seasonal variation, we are first calculating yearly demand and then divide it by 365 to find this rate of demand. And there are various types of demand according to our code. What is the code? 1172 1993. There are various types of demand. What are the various types of demand? Various types of demand according to the code 1172/1993, and that too for an average Indian town without full flushing system. For an average Indian town without full flushing system. This without full flushing system means we are talking about rural areas here. Means in rural areas mostly we use Indian type toilet, that is without that toilet has no flushing system, right? So we are dealing with rural areas here, or low income group. We are talking about the toilet use among low income group. So here domestic demand is about 135 LPCD. 135 LPCD. This was asked for many times. This is a previous question. Then industrial and commercial demand 70 LPCD, public demand 10 LPCD, and losses and theft 55 LPCD. These are the various types of demand according to the code 1172/1993. And this demand is for an average Indian town with the full flushing system. This is for an average Indian town with the full flushing system. Domestic demand increased from 135 to 200 LPCD. Rest are all the same value only. For industrial and commercial demand 70 LPCD, public demand 10 LPCD, losses and theft 55 LPCD. Apart from this, we have to study water requirement for various buildings. It has been given in the code and asked for many times. And you can see from the table, for factories where bathrooms are required to be provided, their water demand is around 45 liters per head. You have to by heart all these values. I must say, you have to by heart all this value. And for factories where no bathrooms are required to be provided, their demand is only 30 per head, because there are no bathrooms, so demand must be low when compared to the factories where bathrooms are provided. Then hospitals, there you have to study two values. One for big hospital which have a number of beds greater than 100, like super specialty or medical colleges like that. Their cleanliness is a little bit more when compared to small hospital. Good cleanliness means they are using more water, right? So there 450 LPCD, and for small hospitals only 340 LPCD, and for nurses' homes and medical quarters demand is 135 per head, that means 135 LPCD, and for hostels 135 liters per head, for hotel 180 per head, hospitals hospital, offices 45 liters per head, restaurants 70 per head or per seat, cinemas, concert halls and theatres 15 per seat. And for schools, again you have to study two values for day schools and for residential schools. Residential school is having little more demand because students are all living there only, no. So boarding schools or a residential school, they are having 135 per head, and for day school only 45 per head. These are the demands in various buildings. Next we have to study fire demand. You all are familiar with this thing, no? This is known as fire hydrant. So fire demand is demand used for extinguishing a fire, fire outbreak. We all know that, right? While looking at this fire hydrant, we can see there are we can take three streams from each fire hydrant. 1, 2, 3. Three streams. And there is a particular pressure we have to get from this fire hydrant. We need high pressure water jets, no? So pressure required from a fire hydrant is in the range of 1 to 1.5 kilogram per centimeter square. Pressure required from the fire hydrant is in the range of 1 to 1.5 kilogram per centimeter square at a rate of about 1100 liters per minute. At a rate of 1100 liters per minute. And fire hydrants should be placed at a distance of about 100 to 150 meter. Fire hydrants should be placed at a distance of about 100 to 150 meter, and we have to get water continuously for about 4 to 5 hours. So these are the requirements we have to get from a fire hydrant. That is, water pressure should be in the range of 1 to 1.5 kilogram per centimeter square at a rate of water supply rate should be around 1100 liters per minute, and we have to maintain that water supply for about 4 to 5 hours, and fire hydrants should be placed at 100 to 150 meters apart. There are different types of fire hydrant. We can see this is a schematic diagram. This is an actual photograph. Okay, this, some may be red in colors, some may be silver in color. Okay, and there are different equations. There are different equations for calculating fire demand. What are those equations? We have a Quichling's formula. We have a Quichling's formula. Next, Freeman's formula. Buston's formula. National Board of Fire Underwriter formula. National Board of Fire Underwriter formula. Quichling's formula. Discharge, fire demand is calculated by 3182 into root P, where P is population of the city in thousands. Then Freeman's formula, 1 discharge is equal to, fire demand is equal to 1136 into P by 5 plus 10. This is Freeman's formula. Then Buston's formula, 5663 into root P. This is Buston's formula. And National Board of Fire Underwriters formula, Q is equal to, discharge is equal to 4637 into root P into 1 minus 0.01 into root P. This is National Board of Fire Underwriters formula. In all the equation, P is population of the city in thousands. You have to be cautious. P is population of the city in thousands. Okay. Okay, I will give you an example how to calculate fire demand by using this formula. Let's take Kuchling's formula. Consider if we are considering a city of population 1 lakh. 1 lakh. Population is 1 lakh. And we have to find fire demand by using Kuchling's formula. We are going to find fire demand using Kuchling's formula. How we gonna calculate this? Q is equal to 3182 into 1 lakh. Is this correct? No, it's not correct, because population should be taken in thousands. 1000 means we have to remove these 300s. So 3182 into 100, which gives 31820 liters per minute. Its unit is liters per minute. So that's how we calculate fire demand using the equation. So next we are dealing with design period. What is design period? Design period means it's a utility period. It's a useful time period. Okay, it's lifespan. Okay, while considering the design period, we will not make it too large or too small. Too large makes it a burden for the present users while it's construction and operation. It will be a burden for the present users. And if you are making it too small, it needs expansion. It needs expansion soon. So it is not economically feasible. So for water treatment plant, a design period of 30 years is generally adopted. So here, this is only a small portion. Here the only question that will be asked is the design period of various components from the water supply scheme. We have to study design period and design rates. Okay. So, and this is the components that is given in the first column. It's design period and design rate. This design rate we will discuss it later. What is maximum daily demand? What is total demand? We will discuss it later. And for dams are designed for 50 years, and its design is based on maximum daily demand. And for intakes also we will discuss it later. We will study it later. Intakes are having a design period of 30 years, and it's designed based on maximum daily demand. And for main conveying pipe, design period is 30 years, and its design is based on maximum daily demand. Pumps are having the same period of 15 years. It has so many moving parts, no? So its life will be less when compared to other components. Pumps are having a design period of 15 years, and its design is based on 2 times average daily demand. And for rapid sand filter, it is also having the same period of only 15 years, and its design is based on 2 times average daily demand. These two are identical. Both having the same period of about 15 years, and both are designed based on 2 times average daily demand. And finally, water distribution system. It is having a design period of 30 years, and its design is based on total demand. So that's it. Design period. Finally, we are studying about population. Here we are dealing about different population forecasting technique. We have to forecast population now. For example, this is the year 2024. In this year, we are going to build a water. Consider, for example, this year we are going to construct a water treatment plant in 2024. We already studied that water treatment plant is having a design period of about 30 years. So we have to use this water treatment until the year 2054. Right? So we have to calculate the population of 2054, and we have to build a water treatment plant so to satisfy the needs of people, number of people living in 2054. Otherwise, our plant will be a failure. So, we have to forecast the population of 2054. There are many ways for forecasting population, many ways. Like we have a arithmetic increase method. You all must be familiar with this name, arithmetic increase method. Some might study arithmetic mean method, that's also correct. Arithmetic increase method, geometric increase method, incremental increase method, decreasing growth rate method, simple graphical method, comparative method. These are the main population forecasting techniques that we use. Let's begin with arithmetical increase method. One thing you must remember, we cannot randomly select a population forecasting method and apply it over a city. We cannot do that. Each city has some specific characteristics, and based on that characteristics, we have to find a suitable population forecasting method that is best suitable for the city. I will explain that in detail. First, we consider arithmetic increase method. Okay, we are considering arithmetic increase method. Arithmetic increase method. Do you know one thing? The cities, different cities can be classified based on their age. Yes, that's correct. Cities can be aged just like us humans. Some city will be young, some cities will be old, like that. Okay, so arithmetical increase method is suitable for old developed city. What is the speciality of old developed city? What is the speciality of old developed city? Do you know what is the speciality? In old developed city, population will be increasing at a constant rate. I am not saying that population will be constant, but increase in population will be at a constant rate. I will give you an example. I am considering 4 different years, 4 consecutive years, 2010, 2011, 2012, 2013. If in an old developed city, if 2000 at the in this year 2010, if population is 10,000, at the year 2011, consider it increases to 12,000, and in the year 2012, it increases to about 14,000, and finally 2013, population is around 16,000. So population is not constant here. Population has been increased from 10,000 to 16,000. But look at the increment, dp1, consider dp1 as the change in population during the first year, dp2 change in population during the second year, and dp3 change in population during the third year. dp1, that is change in population during the first year, it's around 2000. Change in population during the second year, that is dp2, it is also 2000. dp3 is also 2000. So if dp1 almost equal to dp2, that will not be equal always. If dp1 almost equal to dp2, which is almost equal to dp3, then we can say that the city is an old developed city. Here we can use only arithmetical increase method. If we use another method, if we use geometrical increase method in here, the value will be wrong. Our forecasting will be not accurate. So there is an equation for calculating here. One more thing. Here we assume that what increase in population is constant. That is the assumption we use for making this equation. What is our equation? Pn is equal to P0 plus Nx bar. Pn is equal to P0 plus Nx bar. What is Pn? Pn is the future population. Pn is the future population. And what is P0? P0 is latest known. P0 is latest known population. P0 is latest known population. And N, what is N? Number of decades between P0 and Pn. Remember, N is not number of years, number of decades. Okay. And finally X bar. What is X bar? Average of increase in population. Average of increase in population. And that's how we calculate future population during arithmetic increase method. Okay. Let's do an example. Let's do a problem with this equation, and then you will be thorough with this topic. So let's do a problem in relation with this arithmetical increase method. The population figures of a city is given as follows. During the year 1970, it's around 40,000. Consider it as 40,000. And 1980, the population increased to 46,000 from 40,000. And 1990, population again increased to 53,000. And in 2000, population is 58,000. So we are supposed to find the population in 2020 using arithmetic increase method. How will you do this? Okay, so we can just substitute the values in the equation. We know the equation, that is Pn is equal to future population, that is population in 2020 is equal to P0 plus Nx bar. P0 plus Nx bar. What is P0? We know that P0 is the latest known population, right? What is the latest known population in this problem? That is 58,000. This is our latest known population. So it's so simple. 58,000 plus N. What is N? N is number of decades between P0 and Pn. That is from how many decades are between 2000 to 2020? There are 20 years difference. No, 20 years difference means 2 decades. So N is 2. And finally X bar. X bar, what is X bar? It is the average of increase in population, right? It is the average of increase in population. So we have to find increase in population each year, no? So there should be a third column, increase in population. What is the increase in population during the first year? During the first year, it's about 40, from 40,000, it increased, population increased to 46,000, no? So increase is 6,000, and during the next decade, increase was about 7,000, and during the third decade, increase was about 5,000. So we have to find the average of this. So x bar is equal to 6,000 plus 7,000 plus 5,000, the whole divided by 3, which gives around 6,000. Which gives 6,000. So x bar is 6,000. So we got our final piece to solve the riddle. So just substituting here. So the answer is 58,000 plus 12,000, right? 58,000 plus 12,000. So the answer is 70,000. So at the year 2020, the population will be 70,000. So this is how we solve the problems using arithmetic increase method.
Start your preparations for engineering competitive exams from top educators. Learn from the best.